Okay, let's just highlight our multi-scatter here. I'm just going to select these and press delete. And now we'll go inside our multi-scatter and we'll start adding these things in here. So we have our surface here. These are going to be the scattered points. This is just a null so that we know kind of where we are in the network. And now we'll start copying stuff. So again, we'll press tab and select copy, wire in just like we did before. We're going to press tab and type object merge. We will wire that in. Let's select our test object. And turn that on. So instead of using attribute creates, I'm going to introduce you to something called an attribute VOP. We looked a little bit at attribute wrangle. Let me show you what that is here. Attribute wrangle. And that was a way that we can write little bits of code. So I can do something like this. I can define an attribute. So if I say F, that means we're defining a float attribute pscale. So I'm saying there's a float attribute called pscale, which we're defining, and then I can say that is equal to 0.1, and then a semicolon here to close that statement. And then we create that attribute just like you see. For people that aren't familiar with coding, this may be a bit of an issue, and I tend to look at this more as an intermediate way of dealing with Houdini. It's very powerful in a lot of ways. Being able to just write code is wonderful and can make your setups a lot easier, at least to work with. But for the beginner, this is probably a bit too much. So what we're going to do is make an attribute VOP. And I'm just going to wire that right here. So what an attribute VOP is it is just like that wrangle that I showed you before, except you can see there's no code here. Essentially what happens is when you dive inside, I'm going to press H to home here, you can create code, but it's all done visually. So you make a bunch of little bits of nodes and you wire them together, and then you actually compile the code here. So you can see that there's compile, which you usually don't really have to hit yourself, but it will kind of tell you that it's using Vex. So Vex is the name of the code language that we were writing when we were defining those attributes. Also, if you right click here and you choose Vex VOP options, view Vex code, you will see that you're actually getting code. And when you put little nodes in here, you can see that you get this code produced by, and it tells you the node that's inside and what the code is. So essentially it's writing code, but it's doing it in a visual way. So if I go inside here and I want to create that pscale, all we need to do is this. I just need to press tab and type bind export. And this will create an attribute just like that. Now what it wants to know is the name of the attribute, and I'm going to say this is called pscale. And of course I need to give it an input. So for now I'm just going to put a constant in here. So if I press tab and type constant, that's going to feed a constant value. And I want to make sure that's a float. Just wire it right into here. So you can see it's 0 because we're set to 0. Now if I say 0.1, we now have that attribute called pscale. So if I go up, middle mouse here, you can see we now have pscale attribute, whereas before we did not. And it's set to 0.1. So the only issue with doing things like this with constants is that it's not actually a user parameter. So you see there's nothing that gets propagated up here. And you never want to be animating or dealing with stuff inside of this, because what happens, if you're familiar with code, is that it compiles every time a value is changed inside of here. And that's very, very slow, and that's not really the right way to work with this. So anytime you want to change a value or a variable, you actually want to do it from the top level here. And they have a specific way of doing that, and that's by promoting parameters. So if I delete this and I press tab and create a parameter node, and I just wire that straight into here. I'm going to call this parameter, let's just give it a label so you see the difference here. So if I call this one scale, I'm just going to call it uniform scale. And I'm going to leave that at parm so you can see the difference here. Now when we go up, I have something that is labeled uniform scale, and if I hover over it, you see that the actual code word for the parameter is parm. So I'm just going to go in and change that to call it uniform scale. And now I go up here, and you can see now that I have a slider that the user can play with. So this is great. Let's go back inside. I want to make sure that I default that to 1. We'll go back up. And now we can see that we have a slider that we can play with. So what about doing randomization of the scale here? Well, let's go back inside. You know, we looked at some ways of doing randomization before, just with a little bit of code, but we can do it here kind of a little easier in terms of people who aren't familiar with coding. Just make it a little easier to grasp. We will simply press tab and type the word random, and we get a random. So all random wants to know is what number should I use to create a new random number. So anytime that you use the same number, for instance, if I always plug the number 2 into here, it's always going to output a certain number, and that certain number is going to be consistent every time I plug 2 in. Every time I plug 5 or 7, it's always going to give me a specific value for 5 or 7 that does not change. So we need to figure out a way to use a specific number per point so that each point will have its own random value. And I am going to use our point number for that. So each point number coming in is going to feed into this random value, and it's going to spit out some number in the range of 0 to 1. The other thing I want to comment on here, let me just go up a little bit here, is that right now this is set to run over points. And the way this works is it uses multiprocessor, if we have multi-threading on, and it tackles each point individually. So the points aren't really aware of what the next point in the order of processing is, or necessarily what the other points around them are. It just takes each point like an individual and then does this operation on it. So point number actually refers to the current point number that's being processed. So if I just take random, and I'm just going to wire that into pscale, it might be a little tough to see the scale difference, but we know somehow that we're getting a value between 0 and 1. Now if I take that value that is between 0 and 1 right here, and I multiply it by our uniform scale, and actually I want to put it right in between here. So I just press tab and type multiply. So we have some number between 0 and 1. And now what I want to do is scale that number down by multiplying it by a scale factor, and just wire that right in to our scale. And now we see that each one of these has a different scale here, right? We see some that are very small, some that are big, but that biggest value is going to be 0.181 if it's able to reach there, but usually it never reaches this value. It gets close, but not quite there. What if we wanted to actually define the range of scale here? Well, that's really simple. We just go back here, and I can do this. I can take our random value and I can specifically fit it within a range. So I can press tab and type the word fit and grab a fit range. And our value that's coming in is going to be our random value. And we're just going to take the shift, just wire that right into our multiply. And we know since random gives you a value between 0 and 1, we don't need to change our minimum and maximum of the source. So this wants to know what's the source coming in, what's the source, the minimum coming in, and what's the maximum value coming in. And then what do we want to convert those values to? What range? So right now it's going to 0 to 1. But we can do this. I can just middle click here, and I'm choosing promote parameter. And that will give us a parameter here, just like that. I'm going to double click it and it will unpeg it so you can see. This is a parameter. That's a parameter. That's just a short way of doing that. To collapse the pegs, let's see if I just do, I think it's hide input nodes. There we go. That will collapse the peg. And I can just call this min scale. And we'll call this scale min. Now for the maximum, what I'm going to do is show you another way to promote the parameters. For our destination max, we can just click this little gearbox here and choose promote parameter. And I'm going to click there, and we will call this scale max. And I will call this max scale. And now we'll change the name of this because this isn't really defining the scale. This is more of a multiplier. So we will call this scale multiplier. And again, scale multiplier. Now let's go up. And we can see our min scale, max scale, but I can start to play with these values. And now we can actually define a specific range for our scale. And of course we have our scale multiplier in here as an overall multiplier. What about random seed? So let's go back inside here. Now all we need to do to choose a new random seed would be to change the value that's coming in here. So we can do that simply by adding to our point numbers that are already in here. So if I press tab and type add, just going to wire that in here. Press tab again, type parameter. And I need this to be an integer, so I'm going to change that to integer. And we'll give it a huge range. And we will name this seed. And by the way, you don't necessarily have to add. You could multiply. You could do a bunch of different ways of getting different random seeds. So we will just add right into there. We'll go up a little bit. And now you can see as I change the seed value, our scale is changing based on that. So I'm going to label this copy parameters. We will save this here, choosing save node type. We're going to save the file, and then we'll continue working. Continuing on scale, let's take a look at how to do non-uniform scale in here. So I'm just going to enter here again, and we will enter the copy parameters. And we're looking here at pscale. So we'll need to create another attribute, and they have one specifically called scale. So if I press tab and type the word bind, export, grab the export. This needs to be a vector because it's non-uniform. It has a different scale value for X, Y, and Z. I want to make sure, of course, that our default is going to be 1. And did I do that in scale here as well? I did not. So let's make sure our default for scale is 1, pscale. And this needs to be labeled scale. Now you can see as I dial this up or down, it should change it maybe. Let's see, maybe not. Well, we'll find out in a second here. Just keep it like that. I'm just going to add a parameter here. I'm not going to give this labels. This is just for testing. We'll do a 3 float vector. We're going to end up deleting this in a second here. There we go. Okay, now we can see if I dial this up to 1, 1, and 1. There we go. So if I just want to change Z scale here, I can do the same thing. And you see that it's non-uniform. So it's using each one of these as a different axis to scale upon. So we'll do the same thing. We'll add some randomness inside here. So I'm just going to delete this parameter here. And for now, we're just going to use the same random seed that's coming out of here for our randomness. And we'll use the exact same setup. So we have a fit that we're going to do. I'm going to press tab and type fit. And I'm going to press tab and type random. I'm going to give us a different random here because what we want is well, let's wire it up first because there's too many choices. See, if we do this, we've got a ton of choices. I'm just going to kind of lower our list here. So now we only have this to choose from. I want a 3D vector to come out of here. That means there's going to be a different random value for the X, Y, and Z component here. And you'll notice if I wire this right into our value, that everything turned this different green color, which means it's been converted into a vector signature. So again, I know that we have inputs coming in of 0 to 1 range, and right now that's what our output is. I am just going to wire this right into scale. And then we will promote our destinations. So I'm going to select this and we will call this, what did I call that one before? Call that scale, min scale, max scale. So we'll make sure that this is non-uniform. We'll call it non-uniform scale. We'll just copy this here. And I'm just going to replace min with max. Whoops, didn't mean to unpeg that. Let's hide that input. Grab that, copying, pasting, and just changing the word. And I think it's probably better to default our min to 1. Typically, you're not scaling much in different dimensions and proportions. So this is more to give the user some ability to decide what they want to do after the fact. But so I don't really feel like this has to go through another scale multiplier. This is probably good just on its own. Okay, so that's good for now. I think the next thing to do is start looking at how textures might be able to influence this. So let's go up a little bit. Let's save this. Save our file. And continue. So starting to look at textures. I'm going to change the torus here into a grid. So I'm pressing tab and writing grid, selecting grid. I'm just going to make this 50 by 50. And we'll make this something like 3 by 3. Let's see how, yeah, that's good there. Keep it around the same size we're already at. I'm just going to wire this like so. And let's disable the mountain. It's not really important for what we're doing. So we need UVs if we're going to be working with, if we're going to be working with a texture. So I'm going to press tab and type UV. We will grab a UV texture. I'm just going to do an orthographic projection along the y-axis since that would be looking right down at our grid. Just wire that in and move it right there so those wire together. And I need to make sure that this is a point attribute and not a vertex attribute. Okay, so going into our multi-scatter here, we're going to need a lot of points on here. And before I add a lot of points and go through copying all these pieces of geometry onto here, I'm just going to make this visible here. And let's put 5,000? Nah, 50,000. Okay, 50,000 points is good. I'm just going to middle mouse click here and make sure that we are in fact getting UV attributes, which we are. And now I'm going to show you how to apply textures to these points here. So if I go inside here, and we are inside of our VOP here, we just press tab and start typing the word UV, and we get UV coordinates. So if you have point textures that are UVs, point UVs, they should automatically be read by this node. I'm going to press tab, and we will type the word texture. And this gives us the ability, if I select it, to use a texture map. It's asking what the UVs are, and actually specifically it's going to want the S and T coordinates, which will default to kind of the normalized grid polygon S and T coordinates. A little technical, you don't really need to know what that is. Just need to know that from your UV coordinates, you wire S into here and T into T. And to show you this is working, I'm going to wire our color straight in to CD. And now you can see that the default picture here, which is this texture map called Mandrill, is showing up on our points. So I can promote this so that we can always change what that map is. Now that grays out, and that becomes visible as a parameter here. Now the cool thing is that when I go to copy here, and that's a lot of points, but that's okay. I'm just going to put a null down here because we're getting some of these little viewport selection things which I don't want to look at. And we're seeing a lot of blue. So let me go over to our object, to our test object. Oh, you know what? We don't even need to do that. We can just grab the box before it gets colored as our copy object. So we'll go to Geo, back in here. And I'm just going to grab just the box. Okay, if I go to our copy here, and if I go to attribute, I can actually enable this button, which will copy the attributes from our points and place them onto our primitive objects here. So after doing that, you now see that each of these boxes gets the color of our point. And maybe we can dial our scales down a little bit so it's a little easier to see. There we go. That'll work here. So you can see the way that this copy SOP is. When we choose this, it's going to want to know which attributes am I copying to the point. So what this means is the star means copy everything. And then we have a comma here. And then there's this little hat kind of, I forget what the official name for this thing is. But that means except, like don't do this. So just saying, give me everything except velocity. I don't want to copy velocity. And I don't want to set the alpha here. And that's set here. That's set. So it's going to overwrite any values that are already here. This is the multiply tab. So it's going to say if there already is a value called alpha, I just want you to multiply that. And if there already is a value called velocity here, I'm just going to add to the velocity. So that's it. That's how that works. So let's dial our number down here so that we can work a little faster. There we go. Okay, so back inside here, in our copy parameters, I'm going to dial these up a little bit here. You notice the rotation, by the way, here. That's a little bit of an issue. So that's caused by the polyframe here. I'm just going to turn that off. And for now, we will just create our own attribute for up to make sure that that stays the way we want it to stay. So I'm going to call that attribute up, make that a vector, and we will have our y-axis pointing that way. Okay. So now we have a texture here. We can choose what to do. Do we want to separate the channels out? Do we want to use the red channel, the green channel, the blue channel, or just grab the luminance? For now, I'm just going to use the luminance. So I'm going to press tab and type the word luminance. And just wire that into here. And we'll use that again as a multiplier for our scale. So I'm just going to wire that right into there. And you can see now that it's multiplying our p-scale attribute by the luminance value of that image. Now we need to make sure that we are protected here in case we don't actually have an image. So let's see what happens if we just zero out or if we get into a problem. So we zero out if there's no image. So we'll put our image back in here. And then we may just want to actually switch this on or off. In terms of like just adding a button, like use image button. So let's just do it this way. Let's just press tab and start typing the word switch. So this is going to give us an error right away, and this is a switch just like we used previously. And all we need to do is create a parameter here. So I'm just going to middle click here and select that, and we will call this use texture. I'm just going to label it like that. Now the type is what controls how this appears. So if I go up a level, you'll see use texture has this kind of slider. Go back inside here, and we'll change this to a toggle. And we will keep that off by default. So this will have two inputs. This is 0, meaning if this evaluates false, which means it's not checked, that's what 0 is going to be. And if it is true, then it's going to be the second input. So we want to keep this at 1 since we're multiplying here if there's nothing in here. So all I need to do is make a constant, pressing tab, typing constant, giving that a value of 1, plugging that right into here, and then taking the luminance value and putting that into our second input. And we will just take the result and go into our multiply. So now we have that turned on and off. Cool. Now there's more things that you can do here if you choose to. You can put ramps in here and kind of remap how this stuff works. But for now, we'll do it just like this. So we're going to save this again. Let's save our node type, save the file, and keep going. What about noise? I mean, one thing that you notice here is that when we start using random scales here, you don't get what looks like a very natural distribution, right? It is random, it's completely random. And if I were to change the seed, every frame it just kind of pops around. But if we wanted to use noise, we could. I can simply go here. And what I'm going to do, well, we got a lot of stuff going on, that's okay. There we go, let's just move it like that here. Is I'm going to press tab and I'm going to start typing the word anti and grab an anti-aliased noise, not the flow noise, but this noise here. And that puts down an anti-aliased noise. So it needs a position to drive the noise. So every position in space gives you a different value back. So what we typically do is try to get the position of our points. Now, if we do this and our points are actually sliding around inside of our geometry network, that position is going to change and it's going to look like these points are sliding through the noise rather than the noise sticking to these points. So we can use our rest attribute like we did previously to make sure that we have something that sticks here. So if I press tab and type rest, oh, actually we can't grab that. We actually have to bind it, sorry. So we will bring that parameter into here. So to do that, actually we type tab and type the word bind. Instead of grabbing the export, we grab this one, which will actually import it. We need to manually tell it that it's a 3 float vector. We need to tell it its name. So its name is rest. So what if there is no rest attribute? It's just going to hit 0. And that's why we say use input value if not bound. So that will now give us an input, and we want to make sure if there is no rest value coming in, let's grab our position of our points so we have some kind of a backup. Now we are going to wire rest right into position here. And I happen to know that this outputs values between -0.5 and +0.5, but we don't want our scale to go negative. So we are just going to remap this value. So we'll press tab and type fit, grab a fit range, wire our noise into value. Now here we have to tell it. Our minimum here is -0.5, our positive is 0.5, and we are going to want this to go right now between 0 and 1, that's fine. So I'm just going to grab this and we'll just, again, put that into our multiplier. So we'll promote these. Middle clicking, promoting. And we'll call this min noise and we'll call this max noise. And we will also promote all of this information here. And you know what, before I do that, actually, right now, so this is one little bug in Houdini that I don't like, is our signature right now can't really change. What I want is 4-dimensional noise, and let's see if it works to do this. 4-dimensional noise will give us a noise that we can actually evolve with time. That's the reason I chose this specific kind of noise. By the way, if you press tab and you look here, we have noise and we've got a bunch of different kinds we can choose from, but there's a reason I chose this one specifically. So let's press tab and we will start typing the word vector and grab a vector to vector 4. So that will convert it into a 4-dimensional vector. And let's see if that worked for us. Yes, 40 input, 1D noise. That's exactly what we want. You notice we get this additional component here. So now we're just going to click and promote all of these parameters. Let's move this across here. And then we'll do another kind of switch like we did here and allow enabling or disabling of noise. So we will simply press tab and type switch. Middle click, promote, and we'll call this enable noise. I'm going to say underscore. Make sure that that is a toggle and keep it off for now. Whoa, where'd we go? There we are. Just going to copy our constant here. That will go into this input, and then if we do enable it, we'll go into the second input and just take the result and multiply. Now we'll go back up. Let's make sure this is actually working. I believe so. Yeah. Let's keep everything uniform for now, right about here. I do want to check something because it looks like we're getting values that are not quite uniform. That should be, especially if these two are the same. That should be the same. So I'm not sure what's going on. Let's take a quick look before we start dealing with the noise and find out where that came from. So I'm just going to disable noise, and that doesn't seem to be doing it. And we'll disable that one, just pull that out. And that might be doing it. Oh yes, there it is, because that's coming in there and that shouldn't be. Okay, that's why. So make sure you're not wiring your fit into there but your switch. So we were kind of doubling up on that multiplier. That's what happened. Okay, so now we can enable noise. And we'll keep the range between 0 and 1. And now you can see as I change the frequency, our noise is doing kind of different things here. And we can even dial it way up so it's a little easier to look at. But you have controls here for roughness and amplitude. And the cool thing is that for your offset, if you put something in like $T and you move, you can actually see the noise starting to evolve. Cool. And let's just make sure that that's working. Yes. Great. So we have a bunch of different ways of controlling the scale of objects that are copied here, right in here. And I'm actually going to clarify this. I'm going to call this one scale parameters. And we'll go back up here. Let's save our node. We'll save our file.